Hello guys, and welcome to this video today in this channel. Please, in today's video we shall be looking at how we can solve this differential equation here, because this was just a differential equation that I actually created. Yes, it was equation I actually created, then I posted on social media. Now thousands of students and some teachers were requesting for the solution to this problem, so I've decided to make the solution available today. Okay guys, please, just for a quick reminder, if you're new to our channel, just hurriedly please hit the subscribe button right now and press the bell icon such that each time we upload videos you will be the first person to be notified. And please give the video a like, because that does motivate me enough, and it also gives me the impression that you actually found this content useful. Thank you very much for subscribing, thank you for liking the video, and please, most importantly guys, share the video out with your friends so that they can also be aware that there are good content that are being produced in this channel. And please follow our Facebook page. We shall leave the link to that page in the description below for your convenience. There are so many interesting materials there that are going to be so beneficial to you as a student, to you as a teacher, and to you as a parent that wants to learn. Alright, let's get started. Okay, now as we can look at this problem now, we can see that the equation reads as d squared y by the x squared, which is the same like d cube y by the x cube, plus d squared y by the x squared, all that quantity squared. They want us to find the first derivative of y with respect to x. Now, since I am seeing d squared y by the x squared here, then I'm seeing d cube y by the x cube, then this is exactly what I saw here, right? But it has been squared. So this is a good hint for me to use a suitable substitution. So guys, I'm going to let my u to be d squared y by the x squared, and I know that d squared y by the x squared is simply going to be what? The derivative of the first derivative of y with respect to x. Good. So now I'm simply going to have my, and also I know that what? That d cube y by the x cube is given as what? The derivative of the second derivative of y with respect to x, and this d squared y by the x squared here is simply going to what? U, because it was exactly what I assumed initially to be what? D squared y by the x squared. So this is now going to be d by the x into what? U, which is given as du on the x. Now that therefore means that I'm going to substitute everything I have in the equation. What is my d squared y by the x squared is simply my u. Then my d cube y by the x cube now is simply going to what? My du on dx. Then now d squared y by the x squared is u, then squared. So this is exactly what we're going to have now. So if we now bring this u squared to the left hand side, and we multiply all by dx to separate the variables, and we integrate both sides, we are simply going to have the integral of dx. Yes, we're going to have the integral of dx now to be the same like what? The integral of 1 over u squared minus u. Now if we express in partial fractions now, we are simply going to have the integral of dx, which is the same like the integral of 1 over u plus 1 over 1 minus u du, all that in an integral. So guys, if we now integrate so well now, and we add the constant, because I decided in this case to add the constant but to the left hand side. If you add to the right hand side, no problem, means here is going to be x minus c, not x plus c, but minus c and plus c are constants, so the minus and the plus sign in this case does not really matter. Yeah, so I've added the constant but this way. So I'm going to have integrating dx, I'm going to have my x plus c. Then now integrating the natural log of 1 over u is integrating 1 over u du is simply going to be the natural log of u. Then integrating 1 over 1 minus u du is simply going to what? This is the best friend, guys. This is our best friend. Good. I would love to integrate this man, because the integral of our best friend is simply going to what? The natural log of still our best friend. Great, guys. Yeah, so if we combine the two logarithms, we are simply going to have the natural log of u over 1 minus u. Now if we now take e on both sides, now we are going to have e raised to the power x plus c, which is the same like u over 1 minus u. So if we solve for u now, if we make u the subject, we are simply going to have our u to be e raised to the power x plus c, all that on 1 plus e raised to the power x plus c. Good. But we know that our u was what? What was the value of u? U is what? D squared y by dx squared. So we simply replace that by that is equal to e raised to the power x plus c, all that on 1 plus e raised to the power x plus c. Okay guys, please if there's something you didn't understand, just feel free to leave it in the comment section, and I'm going to reply to it as fast as possible. Okay, as fast as possible. Okay, now let's continue guys. Let's keep in mind that d squared y by dx squared is simply going to be what? The first derivative, in fact is going to be the derivative of the first derivative of y with respect to x. So this is what we have. Then it is equal to e raised to the power x plus c, other than 1 plus e raised to the power x plus c. At this point in time now, it will be so good for us to do another substitution. Now in this case now, we are going to let our dy by dx to be equal to s. You can let it to be h, m, and so on and so forth. Any variable, any free variable you can use guys. You can still let it to be lambda. Good. Yes, it's up to you. Okay, if we let our dy by dx to be equal to s, that therefore implies if we put back the s here, we are simply going to have our this d by dx then into s, which is the same like power x plus c, all over 1 plus e raised to the power x plus c. That therefore implies we are simply going to have now our ds. If we multiply all through now by dx, we are going to have our ds to be equal to e raised to the power x plus c over 1 plus e raised to the power x plus c now dx. Okay, if we now use now the integral on both sides, now we are going to have the integral of ds, which is the same like the integral of e raised to the power x plus c, all that on 1 plus e raised to the power x plus c dx. Now in this case guys, if we now let another substitution, if we let our v, for instance, if we let our v to become the bottom, which is 1 plus e raised to the power x plus c, we'll see that dv turns out to be what? E raised to the power x plus c dx, and it is exactly what we have at the top here. Yeah guys, can you see it? Yeah, it is exactly what we have at the top here, exactly it. So we are indirectly integrating du, all that on what? U, and we know that it is given us what? Natural log of what? U, and integrating ds simply gives us s. Then this is going to be natural log of u, or natural log of the absolute value of u. But since you know that 1 is a positive constant and e raised to the power x plus c can never be negative, yes, it is always positive, so we don't need the absolute value signs in this case. We can just put simple brackets in this case are going to do the job for us. Then remember that when integrates, you always end with a constant. Good. So now we all know that our s from up here is what? Dy by dx. That therefore implies our dy by dx is simply going to be the natural log of 1 plus e raised to the power x plus c plus m, our constant of integration. So guys, this is the solution. This is the solution to this our problem. This is the solution guys. And guys, thank you very much for watching the video, and I hope to see you in the next video guys. The next video is going to be so interesting. As soon as this is done uploading, I'm going to upload the next. So guys, you can't afford to miss it, right? You can't afford. So hurry hit the subscribe button so that you're going to see the video, because I'm going to help you to pass every exam you want to pass, be it biology, be it chemistry, be it physics, be it mathematics, be it further mathematics, computer science, ICT, and so on and so forth, geology. I'm still there. I'm going to help you. I'm going to give you all the helps you need, everything guys. So thank you for subscribing guys, thank you for liking, and thank you for sharing the video out with your friends. Good luck as you prepare for your exams. Thank you for watching, and see you in the next